Hello, my fabulous friends. I'm here today with our very last math lesson for this week. And then guess what? Only 3 more math lessons to go. We kind of timed this perfectly. We will wrap out chapter 11, the very last week of school, and send you off on your way into summer vacation. So get your math book, have a sharpened pencil, and a great attitude to bust out today's math lesson. We are on lesson 11.8, and we are going to be calculating the area of combined rectangles. So what that means is we're going to start to see some more complex shapes today, and we may have to split the shapes into smaller rectangles to find the area of each individual shape and then join them back together by adding the areas. So it'll be a lot of problem solving, but have no fear, your teacher is here to help you along the way. So let's go ahead and get started here. Unlock the problem. All right, so we've got Anna's rug has side lengths of 4 feet and 9 feet. What is the area of Anna's rug? Okay, that's no problem. The first step is we can use square tiles to model 4 times 9, so they kind of showed that for us. It says to draw a rectangle on the grid paper to show your model. Oh, so we need to draw our own rectangle. Okay, so she's making 4 feet and 9 feet. Okay, so let me get my rectangle. So I'm going to go down 4, 1, 2, 3, 4, and we have to go over 9. 4, 5, 6, 7, 8, 9. So go ahead and take a moment to draw a rectangle, just like I did, that covers 4 rows and 9 across. Just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, should be good there. All right, step 3 says to draw a vertical line to break apart the model to make 2 smaller rectangles. All right, guys, now we are smart enough to know that we could right now quickly find the area of this rectangle by multiplying 4 times 9 because area is calculated by length times width. But we're just going to start practicing how to break this down into smaller shapes to make finding the area a little bit more manageable. So I'm going to, let's go 1, 2, 3, 4, 5. I'm going to split my rectangle right here as close to the middle as I can. So I have 5 tiles here and 4 down the side. And then when I look at this other shape, the rest of my rectangle actually created a square. It has 4 across the top and 4 down the side. So if you can visualize with me, I now have 2 smaller quadrilaterals within that big rectangle that was Anna's rug. So now we're just going to calculate each individual area and then put them back together. So let's go to step 3. The side length 9 is broken into, so look, I broke this side length of 9. It was 9, but I broke it into a 5 and a 4 just to make some smaller numbers to work with. Now you could have broken it into maybe a 3 and a 6. I just chose to kind of go somewhat in the middle as best as I could. So now we need to find the area of the 2 small rectangles. So the first rectangle I'm going to trace here in blue. So to find the area, I'm going to multiply 4 times 5, length times width, and 4 times 5, Jeffrey, 20. Yeah, make sure you're paying attention, guys. You know I'm going to call on you. All right, and then the second rectangle, I'm going to trace over in green. And it is a rectangle, even though I can actually call it a square. I'm going to multiply 4 times 4. And Isis, what is 4 times 4? 16. Good job. And so the area of this shape is 16. And now to get the total area of Anna's rug, we're simply going to add now those two areas together. So we're going to add 20 plus the 16. And what is 20 plus 16 equal to? What do you get, Lucas? 36, right? Which is the same thing we would have gotten if we just multiplied 4 times 9 in the very beginning, okay? It says you can check your answer by counting the number of square feet, so you could go up and count all of those squares. I don't suggest doing it. I'm going to verify for you that 36 square feet is the correct answer. So Anna's rug would cover 36 square feet. Okay? Now you're going to find that some of the shapes we break apart further in the lesson are going to be more complex shapes, not just a single rectangle that we're breaking down into smaller rectangles. Because again, I wouldn't have broken this down into two small rectangles. I would have just done 4 times 9 initially. But that was just a practice to lead into how we can break a shape that is a rectangle or a square into smaller pieces, find those individual areas, and then combine them back together. Okay? Let's head over to the next page. We're going to do a connection here. And here we're going to see one of those more complex shapes I was just talking about. So it says, using the distributive property, you found that you could break apart a rectangle into smaller rectangles and add the area of each smaller rectangle to find the total area. So believe it or not, what we just did in that beginning problem was the distributive property. If you recall, the distributive property means we take a bigger number and we break it down into smaller numbers and we distribute the parts to get the total. So it says, how can you break apart this figure into rectangles to find its area? So when you look at this shape, it's kind of like a corner shape, or I don't know, kind of looks like a little boomerang maybe. What we need to do though, we can't just multiply length times width because this is not just a full rectangle or square. There's different parts to it. So we could use a horizontal line and we could split right where they have that dotted line. I'm just kind of tracing along it, not very straight though. And now we have two different rectangles that we can use the formula length times width. So for rectangle 1, let's make it that big rectangle on the top. We have a length of 3 and a width of 7. So we would multiply 3 times 7. In Brooklyn, what is 3 times 7? 21. Good. And then rectangle 2 is actually this square right down here, and it has a length of 3 and a width of 3. So we would multiply 3 times 3, Avery, 9. And then we need to combine those two areas together. So that's our second step, is adding the 21 plus the 9. And what is 21 plus 9, Drew? 30. So we get 30 square units for the total area of that complex shape. Now you could have gone through and counted all the squares, but that's going to take some time. And why do that when we have tools in our tool belt that can help us quickly find the area and feel confident that we are 100% correct? So 30 square units. Now, you might have been looking at this shape up here and saw a different way that you could split it. And they show that in this next example. We could have drawn a vertical line and we could have made 2 different rectangles. But no matter how we decide to split it and find the 2 separate areas, when we combine those areas together, we should get the same answer as we did in the first way. So now let's write our multiplication equation for this first rectangle here, this one that's standing kind of tall. So it has 1, 2, 3, 4, 5. It has a length of 6 a width of 3, so we would multiply 6 times 3. And Ricari, what is 6 times 3? 6, 12, 18. And then for the second rectangle here, it has a length of 3 and a width of 4. So we would multiply 3 times 4. And Brielle, what is 3 times 4? 12. Okay, good. And now we need to combine those two areas. So we're going to add together 18 plus 12. Now this is written horizontally, so if you need to stack your problem up, do that off to the side because that helps you see your place value and when you need to regroup. 8 plus 2 is 10. Drop your 0, regroup. 1, 2, 3. Look at that. We get 30 square units, just like we did the first way. So when we break apart the shape into smaller rectangles, we can find each individual area and then add them back together to get the total. All right, sounds easy peasy to me. Let's work through this. Share and show. It says draw a line to break apart the figure into smaller rectangles. Find the total area of the figure. So it says think. I can draw vertical or horizontal lines to break apart the figure to make rectangles. So you could, my first vision here is cutting this shape right here, making a vertical cut, and now I have two smaller rectangles. But maybe you were looking at this shape a little differently and you thought, well, hey, I'm just going to draw a horizontal line and make those two shapes. Either way will work. Now, since I just drew that line, let's work with these two rectangles. So rectangle 1, we'll do the small one on the top. It has a width of 2. So it's a 2 by 3. So we're going to multiply 2 times 3, and that equals 6. And then, let me finish tracing that. And then the bottom one has a length of 2, and then 2, 3, 4, 5, 6, 7. Okay, so it's a 2 by 7. So then we would multiply 2 times 7, and that equals 14. And so then we would add together rectangle 1 and rectangle 2. So 6 plus 14, what do we get when we add those two numbers together? 6 plus 14 equals 20. So we get an area of 20 square units. We could always check by counting all those squares. We could always check by splitting the shape the other way and calculating the areas, but I'm just going to tell you that we are correct. So let's turn the page and continue on. All right, so it says use the distributive property to find the area. Okay, let's highlight that. That's a vocabulary word. And it says to show your multiplication and addition equations. All right, so we just have some regular rectangles. We could easily just do length times width for the total area, but they want us to break it apart. So I'm going to just break it apart one way and show you there are multiple ways you could break it apart. I'm just gonna, hold on, not with my highlighter. I need to go back to my pen. All right, so I'm just gonna draw a vertical line right here. Okay, so in doing that, I've now just created two separate rectangles. Okay, I've got this rectangle here on the left, and then I've got this other rectangle here on the right. So we need to show what our multiplication would be for each rectangle in order to calculate the area. So for the first one, I would multiply 4 times 3, which equals 12, okay, because it has a length and width of 4 and 3, so 4 times 3 equals 12. And then for my red one here that I so poorly traced, I would have 1, 2, 3, 4, 1, 2, okay, so it's a square then. So 4 times 4, which I know equals 16. So this is showing how I would calculate the two areas. Okay, let me just slide that over. And then to get the total, I would need to add 12 plus 16. And 12 plus 16, 6 plus 2 is 8, 1 plus 1 is 2. So that's 28. So my total area would be 28 square units. Okay, so it is asking for a little bit of work here, guys. You have to break apart. Here's the area, how I'd find the area for that first rectangle. Here's how I would find the area for my second rectangle. And then to get the total, I would have to add those two areas together. So you do need to show 3 different equations, your 2 multiplication for the areas, and then the 1 addition for how you got the total area. Okay, let's go over to number 3 and try that one. Now let's see, number 3, this time I'm going to make a horizontal split. And so I have a rectangle on the top and a rectangle on the bottom. So my first area, and I'm going to write it up top by that one, I would multiply 2 times 1, 2, 3, 4, 5, 6, 7, 8, 9. And 2 times 9, what does that equal, Miss Avery? 18, yes. And then the bottom rectangle, I would be multiplying, I see it has 3 rows times 9 in each. And what do we get, Shyla, when we multiply 3 times 9? 27. And then to get the total, I'm going to add 27 plus 18. Now in this case, I need to kind of write this off to the side because that's a big addition problem to do horizontally. So 7 plus 8 is 15. Regroup. 1, 3, 4. Okay, so that equals 45. So then we would say that the total area is 45 square units. Now you could have broken this rectangle in many different ways. The purpose is though to show 2 smaller shapes, 2 smaller rectangles, find the area of each one using length times width, and then adding them back together. So on your own, of course, you know you're welcome to pause the video, try some of these out on your own. It's not a bad idea to do that. It's a good way for you to test your understanding of what we're doing and seeing if it's making sense to you. But you're welcome to just continue on watching along with me and doing it together. So we are going to continue using that distributive property to find the area, and we need to show our multiplication and addition equations. So I am going to just make a vertical split right here, which looks to be about the middle, and let's take a look at our 2 equations for the area. The first rectangle has 3 rows times 4 in each, and 3 times 4, what does that equal, Hayden? 3 times 4 is 12, yep. So that's for this rectangle here. I don't know where to put it. I'm going to set it right there. And then the second rectangle has 3 rows times 4 in each also. So that would equal another 12. So to find the total area, I'm going to add 12 for the first rectangle plus 12 for my second rectangle. And 12 plus 12, what does that equal, Lucas S? 24. And they already give us our label, so we can just plop 24 in there. We get 24 square units. All right, on number 5, let's, I'm going to make another vertical cut, this time over there. That's just how I'm choosing to divide this into smaller rectangles. You could certainly do it your own way. But for the first rectangle that I created, it has 4 rows times 1, 2, 3, 4, 5, 6. Okay, so 4 times 6. What does 4 times 6 equal to, Adam? Practice our multiplication. Whoa, not 26. That was my bad. 24. All right, so the first rectangle has an area of 24. Let's do the next one. It has 4 rows times, how many in each? 4. And 4 times 4, what do we get when we multiply that? Rowan, what is 4 times 4? 16. So then now we're going to add 24 plus 16 to get the total area. And again, this one might be a tricky one. There are some regroupings, so I'm just going to jot this off to the side. 24 and 16, because 4 and 6 make a 10. Regroup. 1, 2, 3, 4. So the total area will be 40. And again, they give us our label of square units. All right, excellent. Number 6 and 7, kind of the same thing here. We just need to draw a line to break apart the figure into rectangles and then find the total area of the figure. So you might see different ways in which you can break apart these shapes. I am going to draw a vertical line and split into 2 rectangles just like that. You could have easily drawn a horizontal line and chopped that small little rectangle off on the top. However you choose to do it is fine. So my first rectangle, I'm going to multiply 4 times 3 because there's 1, 2, 3, 4 rows, and there's 3 in each row, and that'll equal 12. And then my second rectangle, there's 2 rows, and then there's 1, 2, 3, 4, 5, 6. So then I'm going to do 2 times 6, which is 12. And then now I'm needing to add together those 2 areas. So 12 plus 12, we know is 24. So there's a total of 24 square units in that figure. Now, number 7, they put a go deeper sign there. It's really not a challenging problem except for the fact that it is a more complex shape. So this time we have to cut it into 3 rectangles. So you could cut 2 vertical lines and make 1, 2, 3 rectangles. Or maybe you were looking at this a different way and thought, well, I'm just going to slice that one off the top and slice that other one off the top. And now you have a rectangle here, a rectangle there, and then you have the big long one on the bottom. Okay, either way, we're going to get the same results with the area. So rectangle 1, I'm going to do the small one on the top. It has 2 rows, 3 in each. 2 times 3 is 6. I'm going to do that smaller rectangle, the second one, same thing as the first. 2 times 3 equals 6. And then the long one on the bottom has 2 rows, and this time there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So then 2 times 9 is 18. So to get the total, I need to add together 6 plus 6 plus 18. Oh my gosh, the writing is so hard on this. I know 6 plus 6 is 12, and then adding 18 to that. I don't know why it's all slanted. 8 plus 2 is 10. Regroup. 1, 2, 3. So then our overall total area is 30 square units. High five, high five. All right. Okay, guys, if you need to take a break, feel free to pause the video, go get a drink, go get a snack. Wait a second. We shouldn't be at this page yet. Oh, whew. Oh my goodness, guys. Sorry for that. I thought we were already to the home stretch, but I knew we didn't do the problem-solving page yet. Okay, let's just run through this real quick here. We've got this. Number 8, go deeper. Here we go. A model of Ms. Lee's classroom is at the right. Each unit square is a square foot. Draw a line to break apart the figure into rectangles. What are the area of the 2 rectangles? What is the total? All right, that's just what we were doing. I'm going to chop off this rectangle on the top, and that's how I'm going to break this apart. So for that top rectangle, how would we find the area? What are we going to do, Isis? What are we multiplying? Length times width. So what are our numbers? 3, because there's 3 rows, and how many are in each row? 6. So 3 times 6, Isis, is 18. 6, 12, 18. All right, so then the bottom rectangle, there are 4 rows times how many are in each row, Brooklyn? Oh boy, that's a lot. Maybe I should have split this a different way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 4 times 15? Are we really doing this? Oh, goodness. Okay, we got this. We got this, guys. So 4 times 15. So think of a clock, because every 15 minutes is a quarter hour, and there are 4 quarter hours in time. So 15 plus 15 is 30, and then 15 plus 15 is another 30. 30 plus 30 is 60. I don't know why I typed 50. All right, so now we would need to add together 60 plus 18. And what does that equal? We've got this now. Lucas H., what is 60 plus 18? 78. And we need our label. Each unit square is 1 square foot. So we've got 78 square feet. All right. So maybe if we were to do that again, I would have, instead of cutting my shape that way, maybe we should have split it more like that. And then that would have given us some better numbers to multiply with. All right, so let's try number 9. David has a rectangular bedroom with a rectangular closet. Go figure. Each unit square is 1 square foot. Draw a line to break apart the figure into rectangles. And what is the total area? So let's make a vertical cut this time. And let's cut it this way. All right, so for this smaller rectangle that we created, what will we multiply to find the area? Well, I see that there are 4 rows times 4 in each. So Rowan, tell me again what 4 times 4 is. 16. And then for the larger rectangle, we have 6 rows times 5 in each. So Liam, what is 6 times 5? What is that going to give us? 6 times 5 is 30. So then to get the total area, we need to add 30 plus 16. And when we do that, what are we going to get, Jeff? 30 plus 16. Yep, we're going to get 46. But don't forget, we need our label. Measuring each unit is a square foot. So we have 46 square feet. Okay. Awesome job. So now the next one is a Think Smarter. It has the on-the-spot video, but I don't think we honestly need to use the on-the-spot video because it's just doing what we've been doing. It just wants us to explain how to break apart the figure to find the area. So there could be, again, multiple ways to do this, but I'm going to make a vertical line right here and a vertical line right here. So now I have 3 smaller rectangles. So I'm going to start to explain this as I go. I made 2 vertical lines to create 3 smaller rectangles. Helps if I can spell it. Okay. So now that we made those 2 vertical lines and we have those 3 smaller rectangles, now we need to find the area. So I'm going to keep this over with my explanation. The first one has 1, 2, 3, 4, 5, 6 rows times 3 in each. So 6 times 3, Avery, 18. Okay. And then the second rectangle there in the middle has 3 rows times 1, 2, 3, 4, 5. 3 times 5, and Adam, 3 times 5, 15. And then the last rectangle, what do we get there? Oh, 1, 2, 3, 4, 5, 6, 7 rows times 3 in each. And so, Brielle, what is 7 times 3? 21. Okay. So then we need to add all of the areas together to get the total. So we're going to add 18 plus 15 plus 21 to see what this equals. Now, I do need to jot this over here because that's a lot to add together without it being stacked up to see our place value. Okay. Whoosh. Okay, so let's add this together. 8 plus 5 is 13, plus 1 more is 14. Regroup. 1, 2, 3, 4, 5. Okay, so I got a total of 54. So let's put this back down there, 54. Okay, so then I'm just going to say the total area is 54 square. Oh, and it tells us 1 unit square is a square meter. Do you see that underneath the figure? So we need to put square meters. Okay. So, boys and girls, as long as you are showing your work, that counts as an explanation, but also, you know, kind of giving some words too to tell what you are doing. For instance, I made 2 vertical lines to create 3 smaller rectangles. And then I showed the work for finding the area of each rectangle and how I added all 3 of those areas together to get the total area of 54 square meters. All right, not too bad. All right, number 11, interpret a result. Use the distributive property to find the area of the figure at the right. Write your multiplication and addition equations. Same thing we've been doing, guys. Just practice, 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 cutting shapes into smaller rectangles and finding the area. So I chose just to make a split right there. Kind of looks like the middle to me. There's 1, 2, 3, 4, 5, 6 across the top on my first one. 1, 2, 3, 4, 5 rows. So my second rectangle would have 5 rows. 1, 2, 3, 4, 5, 6. Oh, I guess I did split it directly in the middle. So for the first rectangle, I'm going to multiply 5 times 6. And what is 5 times 6 equal to, Rowan? 30. And then the second one is going to be the same thing. 5 times 6 again, which equals 30. And then to get the total, I need to add 30 plus 30. And Shiloh, what is 30 plus 30 going to equal? 60. And it tells us we are measuring in square centimeters. So we need our label on there. Don't forget your label, Jeff. Square centimeters. Okay? All right, not too bad. Think smarter, though. All right, Pete drew a diagram of his backyard on grid paper. Each unit is 1 square meter. The area surrounding the patio is grass. How much more of the backyard is grass than patio? Okay, so this is a 2-step problem. How much more is grass than patio? So let's look at the patio. How many square units does the patio take up? Well, you can't see the individual squares, but my mind can imagine that they're there. So the patio is 4 square meters. So now we need to find the area of the grass. So I am going to make a horizontal cut right here. So now I have this small shape, square, and the one over here, and then I have this big chunk of grass. So these two smaller ones I can see have an area of 4. I'm just putting dots on them. I can count those quickly. So I know 4 plus 4 is 8. So let me just jot that down. And then for the large chunk of grass, there are 3 rows and 1, 2, 3, 4, 5, 6 going across. So 6 times 3 is 18. So let's add 18 plus 8 to get the total of the grass area. Get rid of this for now. So 8 plus 8 is 16. Regroup. 1 plus 1 is 2. Okay. So I calculated the grassy area to be 26 square meters. And the patio was only 4 square meters. So we want to know how much more of Pete's backyard is grass than patio. So now we need to subtract those two. 6 minus 4, Liam, what does that equal? 2. And then 2 minus nothing, 2. So we just figured out that the grass is 22 more square meters than the patio. So there's 22 more square meters of grass in Pete's backyard than patio. Okay, so real life problem there, just giving an example of how we can break apart a larger area into smaller figures, find the area of each, and then in this case we were comparing 2 parts together. Now's the moment we've been waiting for, the practice and homework home stretch. Almost done, guys. Hang with me. So, number 1, already done. Skip to number 2. We need to use the distributive property here, split apart this rectangle, and show our work. I'm going to make a cut right there. I see my first rectangle has 3 rows times 4 in each. So 3 times 4, Ricari, shout it out. 12. And then the second rectangle, 3 rows times 5. And Lucas asks, what is 3 times 5? Shout it out to me. 15. Oh my gosh. You guys are so smart. And to get the total, we're going to add 12 plus 15. And what do we get? 12 plus 15 for the total area. The 2 10s make 20, and 5 and 2 make 7. So 27. And we don't know what we're measuring in, so we're just going to say square units, which they already gave for us. So 27 square units. Awesome sauce. Okay. Number 3, let's split this shape into smaller rectangles. I think I'm just going to slice the top right off of this. Whoop. Okay. Now you could have split it a different way, but my first rectangle is going to be 2 times 5. That equals 10. And then the second rectangle has 3 rows, and there's 7. So that equals 3 times 7, 21. So now I'm going to add together 10 plus 21. And what does that equal? 31. Oh my gosh, you guys are so smart. Okay, 31 square units. Okay, number 4, 5, and 6. All right, Frank. A diagram of Frank's room is at the right. Each unit square is 1 square foot. Draw a line to divide the shape of Frank's room into rectangles. What is the total area? All right, now this is a pretty big shape. So, I mean, I see that I could split vertically right here, but if the second rectangle still looks too big, split it again. It doesn't matter how many smaller shapes you make. In the end, you just need to make sure you add up all of those areas. So let's calculate the area of this first rectangle. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5. So what is 6 times 5? Whoa, you guys, you didn't raise your hand. Just kidding. All right, 6 times 5 is 30. Let's do the small rectangle on top. There's 1, 2, 3, and then 1, 2, 3, 4, 5. So length and width, 5 times 3 is 15. And then the other rectangle here, 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5. Oh, so 6 times 5 again is 30. And now to get the total, we just need to add together 30 plus 30 plus 15. Oh, my fingers hurt so bad sometimes after pointing and clicking. Okay, you didn't care to know that probably. All right, the ones place adds up to be 5, 3, 6, 7. Whew, 75. Yes, we're right. All right, total area, 75 square feet. Okay, you know we're skipping this one here. So over to lesson check number 1. The diagram shows Ben's backyard. Each unit square is 1 square yard. What is the area? Let's just do length times width. 3 times 6. Right? 1, 2, 3, 4, 5, 6. Yeah, 3 times 6 is 18. And we're measuring in square yards, so 18 square yards. I did not need to break that rectangle into smaller parts, although I could have, but why do that when it's already a rectangle? Now, this next one here, we do need to split it. I'm going to make a vertical cut. All right, let's do the area of the first one. So that would be 3 times 1, 2, 3, 4, 5, which equals 15. So the first rectangle's area is 15. And see how quickly I came up with that? I didn't have to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Just length times width. All right, so the second one is going to be 5 times 3, which is also going to be 15. Okay, and then we add together 15 plus 15 to get the total area, which would be 30. And since this is an art gallery and each unit square is a square meter, our label is square meters. All right, don't forget your label. I know someone's gonna do it. Don't let it be you. All right, spiral review. Yay. Number 3, Naomi needs to solve 28 divided by 7. What related multiplication fact can she use to find the unknown number? Well, Naomi, lucky for you, my 3rd graders are excellent with their multiplication. So what would we do? What would we use? Well, we're going to do 7 times something that equals 28. And we should probably fill in the answer there. So 7 times 4 equals 28. Or it could be 4 times 7. We know we can flip around our factors because of that commutative property. All right, number 4, Karen drew a triangle with side lengths of 3 centimeters, 4 centimeters, and 5 centimeters. What is the perimeter? Okay, guys, remember, perimeter is when we are finding the distance around. So if we have, I don't know, this is just a quickly drawn triangle, 5, 4, and 3, and we want the perimeter, we just need to add up all the sides. So what is 5 plus 4 plus 3? What are you going to get, Jeff? Okay, if you're saying 12, you are correct, and our label is centimeters. Each side was measured in centimeters. All right, number 5, the rectangle is divided into equal parts. What is the name of the equal parts? So how many parts are there, Isis? 1, 2, 3, 4. So what do we call parts of 4? They are split into fourths. That's all there is to it. Each part is a fourth. 1/4, 2/4, 3/4, 4/4 creates the whole rectangle. All right, and number 6, use an inch ruler to the nearest ½ inch. How long is this line segment? I just don't have a ruler here on my computer to pull up. I mean, I'm sure I could find one, so I'm just going to cheat and tell you that it's, oh boy, what did I do? Okay, maybe I shouldn't have said I was going to cheat. It's 2 inches long. You can measure it out visually, but if you have a ruler, check it out. But otherwise, 2 inches and we're good to go. All right, guys, math is done for this week. Pat yourself on the back. All right, we survived. 1 more week left, guys. 1 more week. We have 2 more lessons and then the end of chapter 11 review. There are some extra resources on Google Classroom under Math for Chapter 11 if you really want to go above and beyond. There's some reteaching pages on the lessons we've done. There are some enrichment pages if you are up for a challenge. There's some practice tests and things you can do. I know it's kind of hard to get motivated these days, but it's something you could always come back to over the summer just to continue your learning and better prepare you for 4th grade. All right, so anyways, I'll stop blabbering. Have a great day, guys. Tune in next week for our last 3 math lessons of 3rd grade. I'm so proud of all of your hard work. Talk to you later. Bye.